I'm going to show some examples of trigonometric integrals. Some general guidelines is to split off pieces of the integrand and use Pythagorean identities with u substitutions, power reducing formulas, integration by parts, different things like that to try to make it integrable. And so it's kind of like when you used to verify trig identities. You have to try different things out and see what will work for you. So several examples. All right, integral of cosine cubed sine squared dx. And so realizing that the derivative of one is the other with a negative or not, that's going to help us out as far as splitting things off. So what we'll do is split off one of the cosines. So we have cosine squared sine squared dx. And now we can use a Pythagorean identity to change the cosine squared to a 1 minus sine squared. So that was cosine squared to 1 minus sine squared. Distribute these guys and put the cosine at the end. So now what you see is if we make our u equal to sine x, our du is cosine x dx, so there's your du. Here's our integral, simple power rule, and then we plug back in sine x. Okay, in this case, we have an even power, and we have no other trig function around. So what you do with an even power of sine or cosine when it's on its own is use a power reducing formula. And so it's 1 minus cosine of 4x over 2. So I brought the half out front. Because it's sine, this would be a minus. If it was cosine squared, it would be a plus. 2x, you double it, you get 4x. So half's out front, and you integrate each piece of this. So it's x minus a quarter sine 4x, of course, plus c. There you go. Integral of tan squared dx, Pythagorean identity. Tan squared is the same as secant squared minus 1. Integrate each piece, and you get tan x minus x plus c. Over here, again, we'll have to use Pythagorean identities, perhaps. Well, actually, because the derivative of tan is secant squared, there's not too much to do here. U is tan 2x, so du is 2 secant squared 2x dx. That's what du will be. And so I have a secant squared 2x dx, but I need to put a 2 in there. And so that's going to be compensated by a half out front. So now I have this integral, and that becomes 1/2 integral u to the 5th du, because this is your u to the 5th. Here's your du. Simple power rule, and plug back in your u. Okay, for this one, again, a lot of it is just trying out different things and hoping it works. If it doesn't, try something else. So in this case, I'm changing everything to cosines and sines. So now I have this integral here. Okay, and what I will do is split off a cosine. I will change the cosine squared here to 1 minus sine squared. I imagine there's different ways to set this up with different u substitutions. This is just one idea. And so now what I can do is combine this together by dividing. So this is sine to the negative 2. This cancels to 1. Now if I make my u equal to sine t, here's my du. I can rewrite my integral in terms of u's. And so now I use power rule again and plug back in what I have for u. And then finally I can just rewrite it a little bit to look like this. Last one, more going on here. Integral of secant cubed, and we've got the pi is going to add a little bit to it, but the main thing is the fact that it's integral of secant cubed. A lot goes on in this one. So first of all, I'm going to let this whole integral equal a. That'll be useful later. So I split off one secant. So I've got secant times secant squared, and I'm going to use integration by parts. Integrate by parts, this will be my u, the rest is my dv. So therefore, du is all of this. This is involving chain rule. And v then is 1 over pi tan pi x. So it's uv. So a again is, here's my uv minus v du. So u is secant pi x, v's over here. So these two together minus v du. All right, and then I'm going to use a trig identity over here, this particular one. So I will leave this the same, and then on the inside, I will change the tan squared to secant squared minus 1. And then write this, distribute this, and write it as two separate integrals. Now, this is what we began with, so that's a key point here. So actually, this is a. And we're trying to solve for a. That's really the whole point of this. So what we can do is add a to the other side. Then we're left with this integral. This one, integral of secant, is lens secant plus tangent, plus we've got the 1 over pi because of u substitution. So we're almost there. We have to. The whole point was to get this a. What we decided would be a was the integral of secant cubed. So we have to divide by 2. So 1 over 2 pi, 1 over 2 pi. And dividing c sub 1 by 2 is just a different constant, so that's why I chose a subscript here and not a subscript over there.